Ready? Okay, so what we're doing is we're going to start talking about limits. All right, y'all. Okay, so we're talking about limits today. You may have heard of that from pre-cal. You may not have. Either way, it's okay. So we're going to kind of approach it as like it's a brand new topic, but it's fairly easy if you'll just take it for what it is. All right, so whenever you see f of 2, that's something that we already know. F of 2 just means what is the y value when x is 2. So you look at your graph. When x is 2, y is 4. Okay, that's normal. Okay, that's nothing new. But whenever you see it written like this, the limit as x approaches 2 of f of x, okay, what this means is when x approaches 2, the y value is what? So you have to go towards 2 on your graph. As you're headed towards 2, where's the graph headed? Up to what number? Well, as you go towards 2 from both sides, do you see how it's headed towards 4? So the limit as x approaches 2 is 4. Okay, it's where's the graph headed from both sides when you go towards this number? It is, but it's not always going to be the same answer. Okay, it's not always going to be the same. That's why we have to have 2 different ways to say it. This means what is the function value of 2? And this means where was the graph trying to get? Okay, and you'll see in another place, make sure you're muted. You'll see in another place that it's not always going to be the same answer. And then continuous just means you could draw this whole graph without picking up your pencil. So yes, this one is continuous. Okay. So this is just a new notation. All right. So now on this one, if I ask you to tell me the answer for f of 2, does it have an answer? This first question, because there's a hole in the graph, right? So what you're going to say right there is that f of 2 is undefined because we don't know. But if I ask you the limit, there is an answer. Where was the graph trying to get on either side of 2? Where was it headed towards? It was still headed towards 4. So you can have a limit even if you have a hole in the graph. Okay? So this means when x approaches 2, the y value is still approaching 4, even though there was a hole in the graph. Would this graph be continuous? No, because you had to skip over that spot. So no, that one's not continuous. Okay. So no big deal. All right, for this one. First off, what this graph is supposed to look like, it's a line, it's got a hole in it right there, and a more line. And this little circle right here, it was actually supposed to be the hole up there. It got shifted, so just cross that out. It's not really there. There's nothing down here. Pretend it's not there. So if I ask you on this graph, what is f of 3, what would the answer be? Here's the x-axis. So at f of 3, our answer is undefined. But is there a limit as x approaches 3? Yeah, what's the limit? Where was the graph headed? You look on both sides of the 3. When x is 3, it was trying to get to 4. It's not always going to be 4. That's coincidence. Is this one continuous? No. So that's very much like the last one that we just did. Okay. All right, this next one, it was supposed to look like this with a hole in it right there. I know it kind of didn't show up real well, but there is a solid dot right here, and this dot right here is not there. Pretend you don't see that. So it's supposed to look like this right here. So you have your graph, you have another dot, and then this thing down here was a mistake, not supposed to be there. So what is f of 1? What's the function value of this graph when x is 1? Does everybody get that that would be 1? Because it's where the dot is, okay? So f of 1 is 1. But the limit as x approaches 1 means if we are traveling along this graph on both sides of x being 1, where was the graph trying to go? So the limit is 2, but the function value at 1 is 1. So you need to understand the difference in these two things. The limit is where the graph was headed. The function value is where it actually has a point. All right? And this graph is also not continuous because you would have to pick up your pencil and then put your dot and then continue the graph. So it's not continuous. All right? All right, so now down here, we have a piecewise function, all right? It says, what if there's two sides? So if I'm looking at this graph right here, I'm going to skip down to this part right now. We'll fill this in a second. I'm going to skip down to here. Notice this says x approaches 2, and it's got a little minus behind it. Do y'all see that? It's really tiny, but there's a 2 with a minus. This one over here says x approaches 2 with a plus. That does not mean -2 and +2. What 2 with a minus means is from the left. Okay, and 2 with a plus means from the right. That's going to be really important for you to understand. Whenever you see limit as x approaches a number with a negative behind it, that means from the left side of the graph, and the plus means from the right side of the graph. So if I'm looking here, when x is 2, right? So I'm looking right here when x is 2. If I'm traveling from the left side of 2, I'm following this path. Right when I get to 2, where was my graph headed to? As I went towards 2 from the left, what was my y value? 8. It was trying to get to 8. If I head towards 2 from the right side, where was this one trying to get to at 2? 3. Okay, so if you only follow the left side, it was going to 8, and if you follow the right side, it was going to 3. So you can have a limit, a left-sided limit and a right-sided limit that aren't the same, okay? Now, the overall limit right here, this thing right here in this box, super, super important. For a limit to exist at a number, the right and left-hand limits must be equal. So that if they ask you the limit as x approaches 2, for this graph right here, the limit as x approaches 2, you have to write that it does not exist. DNE does not exist. Okay? Because they're not the same. For a limit to exist, the left side and the right side have to be headed to the same point. And this is just the way it's written mathematically. Limit as x approaches a number from the right has to equal the limit as x approaches the number from the left. So it's kind of obvious. If I ask you the limit as x approaches 2 and you get 2 different answers, then the answer does not exist because you can't have 2 different answers. Nope. Okay, and you'll see. We're going to do some more practice and you'll see. Okay, any questions before I go on? Okay, so for this. All right, so it's a piecewise graph. So they've graphed a line, -x plus 1 is this line. But they only graphed it for the domain x is less than 2. So when x is less than 2, you have this line. And when x is greater than or equal to, which is greater than or equal to 2, it's this parabola. It's a negative parabola that looks like this. So they've already graphed that for you. All right. So we're going to use this graph to answer these questions. All right. So f of 2, your x-axis, you might want to draw that in. It's kind of hard to see. There's your xy axis. Okay. So the function value at 2 would be what? So when it's worded like this, what does that mean? F of 2. What do you think? So when x is 2, which y value do we have here? We have 1. Okay. So f of 2 is 1. Then we go to the limits. The limit as x approaches 2 from which side? What does the plus mean? That means from the right. So if I'm headed towards 2, I'm traveling along this from the right side, headed towards 2, where was I going? To 1. Yep, it's pretty easy. If I'm headed towards 2 from the left, I'm traveling down here. 2 from the left, where was that one headed? -1. So what's the limit as x approaches 2? It does not exist because they're not the same. Now, they don't have to only ask you questions at the place where the graph breaks. They could ask you limits anywhere along the graph. So the limit as x approaches 1. So I'm headed right here. What is the limit as x approaches 1? I've got to check both sides. Where was it headed in from this side? What y value is it headed towards? You see how it's 0? From this side, it was also headed to 0. So the limit as x approaches 1 is 0. If they don't put a plus or minus behind it, you have to check both and make sure that they're the same. This right here, I'm going to write this a little larger so you see. This says the limit as x approaches -1. Does everyone understand the difference between this notation, limit as x approaches -1, and the limit as x approaches 1 and the minus is behind it? This one is actually looking at the graph as we go towards -1. This one is saying limit as x approaches +1 only from the left side. Okay? So where they place that negative sign makes a big difference. So be careful with that. So this is not the one that we're doing right now. We're doing this question. The limit as x approaches -1. This one's a little different, so make sure you're watching. What did I tell you have to do? If it just has the limit and there's no plus or minus, you've got to check both sides, right? Well, there's not even another side over here. If you ever have an endpoint on the graph, you don't have to check the other side. You only do from the side that the graph is headed towards. So where was this graph headed towards at -1? When x is -1, our graph was headed where? I think that's 2. So it can have a limit without the other side. If the other side of the graph isn't even there, if it's an endpoint, you don't have to worry about two sides. Okay, so endpoints are still okay to have limits. All right, so that's the only time you don't have to check both sides is if you're at an endpoint. Okay. All right, so this section down here, they're wanting you to draw in your own graph. So you might want to use a pencil or you can erase on ClassKick, whatever. So if we graph x² + 1, that's a parabola. Over 1 up 1 is the next dot. Over 2 up 4 is where you would find the next one. And it would be symmetrical. But are they wanting you to graph that entire parabola? They only want you to show the side where it's greater than or equal to 1. So we want to erase this part. We only want this parabola from here over. So this side of the parabola from 1 over, because that's what our domain is saying right there. And then the other part of the graph is linear. 2x + 3. So you go up here to 3 and your slope is 2. So I'm just going to keep working backwards. So I have a line that looks like this. Okay. Is this graph the way I have it right now on my page? Is this a function? No, because do you see how I have two values at 1? One of these isn't correct. One of them needs to be an open circle. Which one should be an open circle? The linear or the parabola? Which one should be an open circle at 1? The linear, because it has less than 1. It doesn't say it can equal 1 right there. So this right here is an open circle. Okay, so you have to be really careful with these. I'm going to go ahead and draw this in now that I know what it looks like. So I have the graph drawn. Now you can answer these questions at the bottom. The limit as x approaches 1 with a minus. Which one is that, left or right? Okay, a minus sign means from the left. So if I'm headed on this graph towards 1 from the left, my y value is trying to get to what? What do y'all think? 5. The y value, if I'm traveling along here from the left, it's going to 5. But if I'm going towards 1 from the right, I'm on this branch over here, it's going to 2. I'm going to skip this one for now. So what's the limit as x approaches 1? Do they match? D and E does not exist. Okay? If the two limits don't match, it does not exist. Do you have a question? I feel like this top is like not as, there we go. All right, the limit as x approaches 2. What do y'all think about the limit as x approaches 2? As x approaches 2, is it going to the same place on both sides? Well, what number is it headed towards? Oh, I've got to make a perfect 5 again. Oh, not as good. Those pressure. All right. Questions on that one? All right, I'm gonna come over here and do this next one. So we're gonna graph it. Negative x, negative x plus 1. All right, so, hey, I'm recording this for later to post. So I'll have all y'all's conversation in here. Negative x plus 1 is that line right there, but I only want to see the side of that line when x is less than or equal to 2. So I really don't want any of this part down here that's greater than 2. Is it making sense how to graph these piecewise functions? I know they're kind of annoying because you see them and you're like, oh, that's like double the work. I've got to graph 2 different things. But they're not that hard if you'll break it down into 2 separate parts. Okay? Not YouTube. Canvas. All right, this one down here. How do you graph just y equals -2? It's just a horizontal line. Remember, y equals -2 is just a horizontal line right here. At -2, should I have an open circle or a closed circle? Open circle because there's no equals on there. So it looks like that. So this graph is here, open circle here. Okay. So the question says the limit as x approaches 2 with this little negative sign right here means from the left. So if I'm headed towards 2 from the left, where was this graph headed? -1. But 2 from the right, the graph was headed to -2. Does the limit exist at 2? No. What if I asked you this question? The limit as x approaches 1. Does the limit exist at 1? What is the limit as x approaches 1? It would be 0. Does anybody have a question about this one?
Wait, so previously on like the bottom problem, I think it was A, like f(2).
Okay.
You put 1 there, so why is it 1 there, but
Are you talking about right here?
yeah, A, yeah.
Okay, the question was, why is f of 2 1 and not -1? If I ask you the limit as we go towards 2 from the left side, the answer would be -1. But if I want the function value at when x is 2, where did I put, if I was graphing an ordered pair, my ordered pair for 2 would be 2, 1. That's where the dot goes. This down here, I didn't ask for f of 1 or f of 2 or f of something. If I asked this question down here, if I said, what is f of 2 on this graph right here, what would the answer be? When x is 2, the dot is colored in at -1. Does that make sense? Limit is different than function value.